Ever heard physics called the queen of sciences? Makes
Mm,
you wonder, is
yeah,
there like a more powerful force behind the scenes?
right.
Maybe an empress calling all the shots?
Interesting.
Today, we're going on a deep dive
Yeah.
into this really fascinating and sometimes kind of mind-bending
Okay.
relationship between math and science.
Cool.
Our guide for this journey is physicist Don Lincoln
Oh, cool.
and his insights from his Big Think article.
Awesome.
I'm really excited to dig into this.
Me too.
It's a question that has sparked debate for centuries, hasn't
It
it?
really has. Yeah.
Which field truly holds the key
Hmm.
to understanding the universe?
That's the big question.
Right.
Yeah.
And to make things even more interesting,
Okay.
Lincoln himself actually calls physics the queen in his article.
Oh, haha.
But I think that just kind of adds fuel to the fire.
It does. Yeah.
So before we get too deep into Lincoln's thoughts,
Okay.
let's turn the question to you, the listener.
Sounds.
Do you think math is the foundation of everything?
Hmm.
Or is it more like a super powerful tool in our quest for knowledge?
Yeah, I like that.
Keep that in mind as we explore this further.
Okay.
It's easy to fall into the trap of thinking about knowledge
Mm-hmm.
as a hierarchy.
Yeah.
Like the idea that sociology is built on psychology,
Okay.
then biology, chemistry,
Right.
and finally at the bottom of it all, physics.
Yeah.
Like physics explains
So
everything.
reductionist view.
Yeah, like some sort of scientific food chain
Uh-huh.
with the most fundamental field at the bottom, right?
Exactly.
So where does math fit in?
Hmm.
Is it the bedrock on which even physics is built?
That's a good question.
To answer that,
Yeah.
I think we need to tackle a bigger question first.
Okay. Yeah.
What exactly is math?
Right.
Lincoln argues that math,
Okay.
at its core, is pure logic.
Interesting.
It's a system where we start with objects,
Hmm.
often numbers.
Okay.
We define the rules that govern them. And then, using logic, we explore the consequences.
Makes sense.
So it's like a self-contained world of thought.
I see.
So it's not necessarily bound by the rules of the physical world.
I like that.
That's where it starts to feel different from science, right?
Okay.
Because science is all about observing
Yeah,
and trying to understand the world around us.
that's true.
And Lincoln illustrates this abstract nature of math
Okay.
with some pretty mind-bending examples.
Oh,
He
wow.
talks about clock math,
Clock math.
where, for instance,
Okay.
11 plus 4 equals 3,
Wait, what?
11 plus 4 equals 3.
That doesn't sound right.
Now, that doesn't sound like the math I learned in school.
I know, right?
It sounds crazy,
Oh.
but it makes sense if you think about it like a clock face.
Oh.
Like, if it's 11 o'clock
Uh-huh.
and you add 4 hours,
Right.
you end up at 3 o'clock.
Okay. Yeah.
What's fascinating is that this clock math,
Hmm.
or modular arithmetic as it's formally known,
Right.
it highlights that math can operate under completely different sets of rules.
Interesting.
And those rules don't have to mirror our everyday experience.
I see.
I think this idea of clock math
Yeah,
could really throw people for a loop
it could.
because it challenges our assumptions about math
Uh-huh.
always being tied to concrete reality.
I agree.
And that's probably a good thing.
It is.
It's like saying, hey, there's a whole universe
Right.
of mathematical possibilities out there.
Exact.
It pushes us to broaden our perspective
Yeah.
and think about math as this incredibly flexible tool for exploring not just the physical world,
Right.
but also the world of abstract concepts.
That's a great point.
That's a great segue into our next point,
Okay.
the role of math in science.
Yeah.
If math is this abstract world of logic,
Uh-huh.
how does it help us understand the messy, unpredictable
Yeah.
reality of the universe?
That's where science comes in.
Okay.
I think it's a master model builder.
Okay, I'm intrigued.
All right.
Tell me more about how that works.
So, think of it this way.
All right.
Scientists observe the universe.
Uh-huh.
They identify patterns.
Right.
And they ask questions.
Got it.
And then, based on what they see,
Right.
they build models.
Yeah.
Simplified representations of complex phenomena.
So it's kind of like creating a map of a new territory, right?
That's a great analogy.
Yeah.
And here's where math becomes indispensable.
Mhm.
Scientists choose the mathematical framework that best fits their model.
So they're not just randomly plugging numbers into equations.
Yeah. No.
They're carefully selecting the type of math that makes the most sense
Exactly.
for their particular model.
It's about finding the right tool for the job.
I like that.
And this careful selection of math
Okay.
allows scientists to do something incredibly powerful.
Oh,
Make predictions.
predictions.
Yeah.
So we're not just describing what we see.
No.
We're trying to anticipate what will happen next.
Precisely.
And the beauty of this is that it allows for validation.
Yes.
If our predictions, based on our mathematical models,
Right.
align with what we observe in the real world,
Okay.
it reinforces our confidence in those models.
Exactly.
It's like putting a theory to the test
It is.
in the most rigorous way possible.
Yeah.
And I bet there's no better example of this than Einstein's general relativity.
Oh, absolutely.
Absolutely right.
Einstein's work is a prime example of how the right application of mathematical logic within a model
Okay.
can lead to incredibly accurate and frankly mind-blowing predictions.
So tell me more about how general relativity fits into this whole math-science relationship. I'm ready to have my mind blown.
Right. Einstein's equations predicted things
Okay.
that had baffled astronomers for ages.
Yeah.
Like the wobble in Mercury's orbit. It wasn't just playing with numbers.
Right.
It was unlocking deep secrets of the universe.
Yeah.
Using math as the key.
So not only did he come up with this groundbreaking theory, but it actually made predictions that could be tested.
Yeah,
That's incredible.
it is.
And those tests,
Yeah,
those observations, they matched up perfectly.
they did.
General relativity also predicted the bending of starlight
Oh, wow.
around massive objects.
Yeah.
Something that was later confirmed during a solar eclipse.
That's right.
You know, when I first learned about that in school, it was one of those aha moments.
Look at that.
It's just amazing to think about gravity
Yeah,
warping the fabric of space-time,
right.
and we can actually see it happening.
It's incredible.
It's mind-boggling, isn't it?
It is.
And, of course, we can't forget
Yeah.
some of general relativity's even wilder predictions.
Oh, like what?
Things like black holes,
Okay.
regions of space-time where gravity's so strong,
Yeah,
nothing can escape,
right.
not even light.
Wow.
And gravitational waves, ripples in space-time, caused by the acceleration of massive objects. Both have since been observed.
That's amazing.
It's like science fiction becoming reality,
Yeah.
all thanks to the power of math.
You know, right?
It makes you wonder, though, if math can predict things with such incredible accuracy,
Yeah.
is it really just a tool?
That's the question.
Or is it something more?
Right.
I mean, maybe it's not just the queen's advisor. Maybe it's the empress calling the shots.
Interesting.
That's the big question, isn't it?
It is.
And that brings us back to Don Lincoln's argument.
Okay.
While he acknowledges the immense power of math,
Yeah.
he ultimately sees it as a tool, not the source of knowledge itself.
I see.
He even suggests,
Yeah.
somewhat playfully,
Uh-huh.
that if a better method
Okay.
for scientific modeling emerged, say interpretive dance,
An interpretive dance.
scientists would embrace it wholeheartedly.
Wow, that's funny.
Interpretive dance as a scientific model.
Ha.
I'd love to see that.
Me too.
But I understand his point. It's about finding the best way to represent and understand the universe, whatever form that takes.
Exactly.
It's not about math being the only way. It's about it being an incredibly effective way.
I agree.
Math allows us to build those models,
Right.
make those incredible predictions, gain those insights.
Yeah.
But it's not the universe itself.
Right.
It's our way of interacting with it
Okay.
and understanding it.
Makes sense.
So if math isn't the empresses pulling the strings,
Yeah.
does that somehow diminish its role or importance?
No, I don't think so.
Not at all.
Not at all.
If anything, I think recognizing math as a tool actually makes it even more impressive.
Yeah.
Think about it.
Okay.
It's versatile enough
Right.
to be applied to so many different areas of science, from the very small, like quantum mechanics, to incredibly large, like cosmology.
I see.
It's adaptable
It is.
and powerful. It's like saying, hey, math, you're not the boss, but you're definitely the MVP on the team.
I like that.
And Lincoln himself seems to agree.
Okay.
He respects both disciplines,
Right.
but ultimately, he says his passion
No.
lies in understanding the laws of nature,
Hmm.
which makes sense given his work as a physicist.
Yeah.
He's driven by the mysteries of the universe.
It makes sense.
It's that drive to uncover those mysteries,
Right.
that desire to make sense of the chaos and find order within it
Yeah.
that fuels so much scientific inquiry.
It does.
And math is the key that unlocks many of those doors.
It's true.
It truly is.
It is.
And it raises an important question for our listener. If math isn't the empress of science,
Right.
but rather this incredibly powerful tool,
Okay.
does that change how you view its role
Yeah.
in understanding the universe?
Good question.
It definitely makes you step back and think
Uh-huh.
about the bigger picture. Math isn't just about crunching numbers
Right.
or memorizing formulas. It's a language,
Okay.
a way of thinking
I see.
that helps us uncover patterns
Yeah.
and relationships that exist all around us.
That's a great point.
And by recognizing its power as a tool,
Right.
we can appreciate its versatility,
Uh-huh.
its ability to be applied
Yeah.
to so many different fields,
Okay.
to unlock new discoveries,
Right.
not just in science, but in other areas too.
That's true.
It's not about crowning a winner in this math versus science debate.
I agree.
It's about acknowledging the vital roles
Right.
they both play in expanding our knowledge
Yeah.
and pushing the boundaries of human understanding.
Well said.
And it's important to remember,
Okay.
this deep dive is just the beginning.
Right.
There's so much more to explore,
Yeah.
both in the realms of math and science. There's always something new to discover.
That's true.
And who knows? Maybe someday we will see that interpretive dance
Right.
model of the universe.
Maybe we will.
I, for one, would be fascinated to see how that would work.
I wouldn't rule anything out.
Touche.
Uh-huh.
So, dear listener,
Okay.
as we wrap up this deep dive, we'll leave you with a final thought to ponder.
All right.
If math isn't the empress of science,
Yeah.
but rather a tool,
Right.
does that change how you view its role in our understanding of the universe?
It's a question worth considering.
It is.
Does it make math more or less amazing?
Right.
Does it change how you approach learning and applying mathematical concepts?
Yeah.
It's something to think about.
Personally, I think it adds a layer of wonder.
Okay.
Knowing that this seemingly abstract system of logic
Right.
can be used to unlock
Yeah.
some of the universe's deepest secrets. It's a pretty awe-inspiring.
It is.
It really does. And
Yeah.
who knows what other mysteries we might unravel using math
Right.
in the years to come.
Exactly.
It's a journey of endless exploration,
It is.
and we're all along for the ride.
We are.
So to our listener,
Yeah.
we encourage you to keep exploring these ideas.
I agree.
Don't stop here.
Right.
Read Don Lincoln's article.
Yeah.
Delve into different perspectives on math and science,
Okay.
and just see where your own curiosity takes you.
That's what it's all about.
Maybe you'll be the one to discover the next groundbreaking model,
You never know.
even if it involves a bit of interpretive dance.
Right.
Until next time,
Yeah.
keep those brains buzzing.
Hmm.
And remember,
Okay.
the world is full of fascinating connections,
It is.
just waiting to be discovered.
That's for sure.